Related work. Web service classification and clustering is a topic addressed from different perspectives such as statistical, stochastic, and novel approaches based on bio-inspired algorithms. Additionally, semantic approaches to describe, discover, and invoke web services have been studied to propose novel clustering algorithms. In this section, a revision of related work is presented considering two trends: reported work that address clustering and classification of web services and clustering approaches based on bio-inspired algorithms. Table 1 presents the main characteristics of related work. Comparison of related work. In 2009, Liang et al. Proposed a method for web service categorization considering keywords and semantic relations between elements of the description. Their proposed methodology involves preprocessing WSDL documents, rough clustering by labeling web services with class tag, and fine clustering. In 2009, Platzer et al. Described a scalable approach for clustering very large service repositories. They use a statistical clustering algorithm enhancing a vector space to support the search of services related to a given query. In 2012, Pop et al. Presented two approaches for service clustering, one inspired by the behavior of the birds and other inspired by the behavior of ants. They implemented methods to evaluate the semantic similarity between services. In 2013, Du et al. Presented an approach for clustering web services based on functional similarity and refinement of clusters using a concept position vector. In 2014, Wu et al. Presented an approach which consists of three modules: data preprocessing, web service tag recommendation, and web services clustering. The first module consists of building a content vector formed with nouns, verbs, or adjectives. Authors use different features and different approaches for similarity computation. For content, use the normalized Google distance; for data types and messages they use a basic match similarity, and for tag similarity they apply the Jaccard coefficient. In 2014, Prakash and Singh compared the performance of evolutionary algorithms, genetic algorithm, differential evolution, particle swarm optimization, and artificial bee colony for clustering 3 real and 1 synthetic data sets. In 2017, Sahu presented a two-step ABC algorithm for data clustering problems. Authors address the 3 problems of the ABC algorithm, such as initial positions of food sources, solution search equation, and abandoned food location. In 2018, Kotkar and Kamat described a web services clustering approach based on cat swarm optimization, CSO, which emulates the social behavior of cats in nature. Automated web services clustering is useful to facilitate service search, service discovery, service composition, and service substitution. Of particular interest is the representation of web services through ontologies, because the purpose of this work is the automatic organization of any collection, public or private, of web service in ontologies and their semantic enrichment by classification and clustering.